the country's building stock is responsible for about 1/3 of GHG emissions in the country. So that is a considerable amount that we have to seriously consider. So let's look at let's have a look at the specific buildings, considering that as a special product. We can say it's a complicated product with an extended period of life. You know, constructing a building would consume different types of building, and at that point it's like large number of products, so it can be considered as such. And let's stop for one moment and think about its service life. Acknowledging the fact that the design life is a very imprecise entity based on the quality of the original construction and the environment in which the building is located, and the quality and the degree of maintenance being carried out throughout the life service life, you could see, you can categorize, you can identify the service life of all the different types of buildings in this kind of service life range. If you look at the public buildings, so I have used some reference here, the report by Professor Priyandas, University of Moratu, and also as per the BS standards, as defining the normal building life as 60 years, the public buildings would last 100 years or more. Private structures such as offices, dwelling, usually you can go up to 50 or 80. So most of the other monumental buildings, bridges, civil engineering structures would last more than 100 years, let's say. So what happens after the service life? So if you look at the Sri Lankan context, now though I have put demolition versus disassemble, the most common terminology, or maybe the concept that is being used in our country, is the demolition. So if you look at demolition versus dismantling, so demolition is very easy to understand. It's like we are trying to take the building down or breaking up. So if you look at the dismantling, it's kind of a process. We are carefully taking off the parts of the building, or rather deconstructing the elements, preserving for the future use. Right. So usually what happens in the country, in Sri Lanka, almost all the demolished structures end up in the landfills. So you can see there is no circularity in this model, which is a linear model. So we take, make, and dispose. So let's have a look at this disassemble and deconstruction concept, where now, for example, we are much familiar with this concept of urban mining, which is applicable for electronics. We know e-waste. The concept of urban mining has been around for more than 10-15 years. And similar to that concept of urban mining, we should be looking at the constructed infrastructure as material banks, where we can deconstruct and extract the available resources that has gone into the construction. So this is the kind of the full potential of the circularity of the built environment. So rather than looking as or maybe the demolished building as a heap of garbage or waste that has to be taken into a landfill, we have to change our thinking to see the usefulness of material. And of course, now identifying in the e-waste management industry, they have realized that, okay, we can mine more pure material like gold, silver, and other precious material by urban mining. And if you really look at the aging buildings as material banks, we will be able to reap much more benefits than what we can even imagine today. And so when you want to believe this concept of material buildings as material banks, at the end of the service life, we can readily understand reusing material reduces the consumption of raw material, definitely. And also, this is the real, the meaning of circular economy, that is preserving the material and keeping it for reuse and recycle. So we are talking about, we are concentrating on material efficiency and the concepts like design for deconstruction. So these are the topics that we have to consider more and more if you are investing in ideas as, so concepts as building as material banks, because we know for deconstruction, you need to think about this deconstruction right at the design and construction stage itself. Right, so let's have a look at what is circular construction. So most of the time, we would like to think the circularity in construction with respect to the material, or maybe closing the material loops only. But if you rather look at it holistically, the circular solutions on the level of material, processes, and building itself as a whole need to be incorporated to make sure the circularity in the built environment, not only material, the closing loop of the materials only. A little bit going further into the most talked, the Sustainable Development Goals, and we have to understand the circularity is a way to achieve the sustainable consumption and production. And also, when we are talking about the built environment, we have to understand that the same is interconnected with the other goals of SDGs among the 17. And we can see that the impact of buildings and the construction sector was recognized as a key contributor to global emissions for the first time at the Conference of Parties COP21 in 2015. So which is something very timely and essential that we all have to understand. And several of the Sustainable Development Goals directly impact on the buildings and construction sector. So I'm not going to take time to go into these areas. I'm sure you are familiar with this 17 SDGs. And circular approaches definitely support the goals of SDGs. So we have to keep that in mind as well. I would like to draw your attention to the NDC submitted by Sri Lanka in 2021. Despite Sri Lanka being a low carbon economy or having a low carbon footprint and also very quite highly vulnerable status right now, we have committed to increase 32% of forest cover by 2030. And most importantly, we have to understand we are planning to reduce GHG emissions by 15%, quite ambitious, isn't it? And that is by 2130. So within the next 8 years, we have a target to achieve. So that is from the power sector, electricity generation. So you can understand most of this energy is consumed in buildings in Sri Lanka. If you look at, it goes as more than 30% of the generated electricity is used by the building sector. So you can see we have a large say in this commitment, and we have to deliver, and the construction industry as a whole has a responsibility to support towards this. So what does that imply? The building sector should act fast if you really need to meet the Paris Agreement by 2050, within the next 30 years. So what does that imply? We need to think differently, and we have to, the future buildings, the theme of our future buildings should be climate resilience, and we can achieve this through different mechanisms. Of course, you have been learning about this probably. The efficient use of energy, efficient use of material, and efficient use of water. So there are ample examples around the world if you really want to go towards net zero achievement. So the way forward in this aspect would be the keywords that we have to go after, like standardization, new forms of collaboration and co-creation processes, digital innovation, education and information sharing. So these are the key elements that we need to incorporate in our thinking and actions. Right. Again, we can see the potential of the building sector for reducing the GHG emissions can be considered as the largest of the all sectors. So this is an opportunity that we should not miss. We have to consider this through design, construction, operation till end of life. Right. So that means whatever the decisions we take during the design and construction stage will impact during the long operational years of a building, as I indicated, maybe 100 or more years till the end of life. So what are the actions we have to take during the design and construction? We should pay our attention to design high energy efficiency standards in our buildings, and we can go for low CO2 emitting material, that is selection of material should be done properly, and efficient construction technology use, and operate to high energy efficiency standards, and using low or no carbon emitting energy as much as possible, and purposeful design for deconstruction, which is an aspect that we rarely invest to think even right now. Again, it will not happen overnight. We have to work hard for it. It will demand revision of our current existing policies, and we have to, of course, develop clean technology with respect to energy and material development. And you have a higher responsibility in that respect. And more, nothing will happen if we do not convince the policymakers and practicing entities. So what should be done? So we would like to get convinced. We have to show them, okay, these are the numbers. We need to have the ability to quantify. Right now, in Sri Lanka, this quantification in the building sector to see how impactful our buildings are at the very, very lower level. If you can say, we don't have our own tools to do that. So we need to see where we are standing. We need to benchmark ourselves. So what is the way forward? So what I am trying to say is, at this point, we have to find the best possible mechanism to quantify the building sustainability. We have to find out which framework should be used. Now, if you look at, I'm sure you are familiar with these two pictures, where you will see a weak sustainability concept versus a strong sustainability case. On your left-hand side, picture A, which is weak, and B, which is more stronger, where everything is embedded inside the whole environment. The holistic thinking should be taken forward if you really need to quantify the sustainability especially in the built environment. Otherwise, it is not going to do the best job. So this is from a recent publication I have done with one of my research assistants, where we have tried to evaluate the methods available for building sustainability assessment. So in short, you can see how circular our buildings by using different tools. So I am proposing, we have reviewed the existing literature to see what are the tools available so far. So we could see there are three types of tools, A, B, C. The passive tools, where you can see the green rating systems, guidelines, checklists, those can be considered as passive tools. And then you guys would look at this energy and ventilation modeling, which is a very strong tool, but it will optimize one life cycle stage of the building, which is the performance and operation and maintenance. If you look at the third option, the whole building environmental life cycle assessment software tools, that will model the full environmental life cycle assessment of the buildings from construction, operation, maintenance, and demolition and disposal. Right. So if I ask you to select the best technique from A, B, or C, what would you select? Because selecting the best assessment tool is important if you want to do a proper analysis, proper quantification, proper benchmarking of our buildings to see how circular your building, how sustainable your building is. So I'm sure you would be agreeing with me if I select the tool C, that is the environmental life cycle assessment of the whole building. So this is the methodology that we all know as life cycle assessment, which is a well-defined methodology, but extended to a very complicated product, which is called a building with an extended life period. So if you see properly, what are the mechanisms available to do a whole building life cycle assessment? Again, we can see there are 3 types of software tools that are widely used. That is the modeling tools that can be used at material level. So you can see building as a product, a complicated product which has hundreds of materials. So you can see the difficulty of using material level tools at whole life cycle building. Then you can see the design tools which are at component level. So you can see we have large number of building components in a whole infrastructure building. Then we have the design tools for whole building. So which is the most convenient way of assessing the buildings. We have found that choosing the appropriate tool for authentic assessment of building environmental life cycle assessment, these are some of the key elements that we have to consider. So if you look at the tools, we have to see they are designed for specific types of buildings sometimes. And they are applicable for specific life cycle stages only sometimes. And sometimes the analytical capabilities are maybe limited, or we have to select which analytical capability that we need. And most importantly, what kind of databases are associated? Is it freely available with it, or we have to import the databases? And also the factors like level of expertise required and the user friendliness of the tool, which is an implication, and what are the input requirements, and what kind of standards are being used within the tool. So those are the parameters that we will have to decide when choosing this the most appropriate tool for our assessment. Then we try to evaluate in this publication the most widely used whole building life cycle assessment tools in the literature during the recent past. So we found that there are numerous tools, and we were able to shortlist 16 tools, most widely used tools as most widely used tools. I'm not going to go into details of each and every tool, but this is how we tried our evaluation. So we tried to look at all these tools with key overarching attributes, how comprehensive the life cycle approach they have used, and how user-friendly the tool is, and contribution, how the tool contributes to the sustainable design of the building. And we try to look at different aspects of the tool with respect to the data inputs, data analysis and interpretation, output results, tool structure, databases. So this was done through a comprehensive questionnaire having about 55 questions. So these are some of the tools that has been shortlisted. We shortlisted 9 tools, and with respect to different tool attributes, we could see the most of the shortcomings were rising with respect to the databases when we try to assess the buildings databases. But with respect to tool structure, most of the tools were okay, or maybe they were kind of achieving the minimum standards. And you can see we were able to categorize all these tools into 5 tiers. And we could see there were different types of tools designed in different regions of the world. And mostly, these are the key findings. So out of the first round of evaluation, we selected 16 tools. You could see more than 80% of the tools had been originated in the European region. So that means most of these tools are not readily applicable in Sri Lanka. And also, there were 2 tools from American, that is, and Australian continents. So you can see a lot of hard work has gone in to this development of life cycle assessment tools in the European region, and they have done achieved remarkable achievements too. And you can categorize these the tools as software, the desktop versions or web-based versions. So those are the 2 types of versions you could see. And you could see, though you have many tools, only less than 20% is freely available. So it is a fact we need to consider when we are considering from our context, from Sri Lanka. Because we are going to start, we are trying to see, we are trying to taste the beauty of this analysis and to get ourselves convinced. When the fees are associated with, sometimes it's not a kind of a motivating factor. And further, we could see, though there are many tools that has been built beautifully and designed beautifully, calculating sophisticated or doing sophisticated analysis, only 30% of the tools are globally applicable, because most of the time the tools were designed for the specific country using specific language, and sometimes a lot of other constraints as well. So, and there were some tools which are readily designed for design of early life cycle stage design. So these tools sometimes are not that detailed when you compare with the other tools. So this is specifically designed for the early design stage. And also, most of these tools needed moderate to high level of skills sometimes, depending on the tool. And some the software tools needed specialized skills like Revit skills and so on. Right. So, so what are the challenges with existing whole building lifecycle assessment tools when it comes to Sri Lanka? So the first thing is it was expensive when we try to see, or at least try to see how we can use them. And most importantly, we have in this region of the world, Asian region, we have local processes and practices which we cannot see in other parts of the world, especially European and American region. And also now, when we are constructing, a lot of transportation is associated. So the building location is important. So this was not possible with the tools that has been designed for other countries most of the time. And also the most important databases that we are using, we are depending on for the calculation are mostly having the data of their specific country. So not Sri Lankan data are available for us to use. And the other aspects such as the complications in the data entry and need of kind of higher skills levels, and sometimes with complicated data entry, and most of the time developed specifically to a specific region of the world. Right. So those are some of the challenges that we could identify. So this, we saw the need of a local tool for assessment of buildings. So if you really want to assess the sustainability of the local buildings, it's important that we have a tool of our own for the country. Right. So this is the outcome of this exercise. We have been working very hard over the last about 2 to 3 years' time, and we were able to put forward to introduce this life cycle assessment tool, whole building life cycle assessment tool. I will quickly show some highlights of this tool so that we will get motivated to see and use this building assessment tools so that we can assess the sustainability of our buildings. So I acknowledge the funding of National Research Council and the team, our team, the building set team. There are a lot of stakeholders who supported this development. This is a freely available online web-based tool with inbuilt material database for Sri Lanka. And right. So what I'm trying to show is, I'm trying to show you some of the examples that we have done using this tool. And this is a process of benchmarking the Sri Lankan buildings, because we have different types of buildings in the country. So if you really want to set a target for different types of buildings, you have to first benchmark the existing building types using a same type of building tool, using a similar database, and using a similar system boundary. Right. Sorry. Okay. So the research is continuing. This is the first step of our first outcome of our research. The first step, we have included in the tool the calculation of global warming potential only. So we have identified that as the most important environmental impact in the world today, that is climate change and global warming. In the second phase, we are planning to go into the other environmental impact categories. But you can do a full life cycle assessment considering all the building life cycle stages for the parameter selected, which is the global warming potential. Right. So with respect to the tool we have developed, we have looked at how the user can use it, the user friendliness, and how comprehensively we can carry out the life cycle assessment, and how we can use this tool so that we can enhance the building sustainability during the design stage. So as I indicated, we have prioritized the Sri Lankan construction methods and processes as much as possible, and we have incorporated the Sri Lankan materials in the database, and we have facilitated the user with a lot of automated backend calculations so that the conducting the life cycle assessment is going to be not very complicated, and especially this has a demolition stage analysis, because many of the tools lack this aspect of life cycle stage. Right. So how we can start, or how we can do the analysis? As I said, we have incorporated all the 3 life cycle stages, that is construction stage, operational and demolition stage. And you can use simple input techniques. You can use the bill of quantities and structural drawings to extract the input data. And the inbuilt database with the emission data will do the rest of the calculations for the user. This is the tool structure. You can see with the arrows indicated, those are the unique features of this tool when you compare to the other whole building life cycle assessment tools. We have incorporated the local construction processes, and especially the earthwork, little bit in detail than the other tools, I would say much in detail. And how the machinery used during the construction stage would interfere or play a significant role in the construction process. We have taken that into consideration in a unique manner. And also we have looked at the replacement during the operational phase. We know there are different building components has different life cycle, different service life. So the replacement is also considered. The demolition phase has been taken in detail, considering the demolition activities, and if necessary, you can salvage a certain amount of material, and then the rest you can put into the landfill. So these are some of the key features of the tool. So I'm sure you will not be able to get a full picture of this, but with the limited time, I will not be able to go through in very much detail. Right. So as of now, our database has 1,000+ data in the with the tool available, and we have different databases which has material, which has machinery data, and transport related data, and as much as possible, we have incorporated the local data through different studies, and also we are, as a construction industry, we are also using imported material. So in such cases, the EPDs available were really useful for us. So this process of extracting material, and it has gone through a rigorous data quality and checking process. So after that only we have incorporated this data in our database. So these are some of the glimpses from our website. So you can assess the tool through this link. And this is the website. You can see we are still in the development stage, but you will see the most important documents which you will be able to use for if you really want to use this tool. Right. Now, as a country, how we can support, how we can get the results, how we can use. Now, if you look at the green building green EUSL rating system, in under 5.1.7, you can claim 1 point for calculating the carbon footprint of your building, as it calls upfront carbon emissions. So apart from that, we can use this tool to optimize the overall sustainability of the building by identifying the material hotspots, construction technology that is related to these analysis, and operational hotspots. So which is essentially will be useful to reduce the, or even during the design stage, you can use this to reduce the life cycle impact of this building. And we can perform extended calculation and estimate the abatement cost and cost of various sustainability options. But with the tool, we have not provided this option right now, but the results that will be generated can be used readily to do this calculation by the user. And I will be sharing some of the results that we are developing at this moment to benchmark the global warming potential of different types of Sri Lankan buildings. So here, these are some of the most widely used or built building categories in Sri Lanka, like hospital buildings, apartment complexes, and office buildings, and shopping complexes. So we have a pool of data or BOQs ready, and we are in the process of assessing the buildings. Around 30 buildings in the queue. So I am sharing you about 4 very summarized results of 4 types of buildings here. Right. So you can, through the analysis using the tool, you could see the results or maybe global warming potential of the building in the 3 building life cycle stages: during the construction, during the operation, and during the demolition. You could see now it's not a new invention to say that operational phase of the building emits the most. That is understood. But in this exercise, we could quantify. You can see what is the kind of construction activity is emitting most. You can see whether it is earthwork, whether it is internal and external finishes, whether it is coming from the substructure or construction site operations, superstructure, or during the energy consumption during the operation, and so on. So you can see the details of it so that you can further analyze and try to understand where it is coming from. So the same exercise for the apartment buildings you can see, and the office building. So you can see the similar trend, but the contributions are unique for each building, for the multi-purpose building. Right. So you can further do your analysis in different life cycle stages as well. You can see now this is a comparison among the 4 projects, and the total emission you can see with respect to different projects. Now, I am not going to go into detailed discussion at this point. If you have any questions, we might be able to have time. Yes. So again, you can see the comparison can be done with respect to machinery use, material use, transportation, energy, water. So the analysis can be as much detail as possible. So these are some glimpses of the analysis, but this is not the total analysis you can see. Finally, you can calculate the global warming potential per square meter per year, considering different service life. Here we have assumed 80 years. So you can benchmark the global warming potential if you select the service life, a unique service life. You can calculate CO2 equivalent, the global warming potential in CO2 equivalent per meter squared per year. So you can see these 4 types of buildings has different types of emissions. You can see the apartment buildings and multipurpose buildings are making more impact than the other 2 types due to many reasons that I would like to discuss with your questions. Right. So as a concluding remark, I would like to place this in record. The circular economy will not thrive if we do not identify the correct business case. So it should be as a business strategy. So for investors and construction clients, we have to show the potential in this as a business strategy rather than just for a sustainability assessment exercise. And also this life cycle assessment can be considered as a very strong tool to achieving the overarching goal of business growth as well. And designing, constructing buildings based on circular principles, closing the loop on building construction and demolition material and building circular cities would provide definitely new business opportunities. This is where we need to highlight and bring up this concept so that we can convince the clients and investors. And apart from creating jobs, application of the circular principles will support the building resilience that we require so much into the future, and it will certainly reduce the resource use. Remember the material banks that we were discussing, and lower the adverse environmental impacts such as global warming potential. So at this point, the tool was able to quantify this global warming potential. Right. So with that, I think I am closing this presentation, and I'm hopeful through the circularity of the built environment, we can make a change. We can make a difference of the lives of the people who are going to live in the maybe next several years on this planet. Thank you so much for your time and listening, and I'm open for any questions and discussions.
Thank you very much, Professor Shiromi. It was very informative.
And your voice is not that clear to us.
On a very timely
I think the connection is not good, right? We
Connection,
can't
yeah,
hear
properly.
properly. Yes.
Nuan, we couldn't hear anything that you said because your connection was weak. Nuan, can you hear us? I think he lost the connection.
Yeah.
Yeah. Anyone who wants to ask question, you can either put them in the chat box, or you can unmute yourself and speak up. Any question to the speaker?
Looks like no questions.
Any
No, I don't
questions
know whether
from Professor Shiromi?
they can't unmute.
You can
themselves.
alternatively put your questions in the chat box
Chat
below.
box, yeah. Again, anyone, your connection is weak, I think. Yes, we can't hear.
Lot of things to discuss. But yeah, we are experiencing a power cut, and that's why
Okay. Yeah.
May I ask a question? Can you hear me?
Yes, please.
Yes,
Yes, Mr. Beals. Yes.
Yes, sir, we can hear you.
Prof. Shiromi, thank you. I think quite nice presentation. Something we should have actually done, I think, many years ago. But I think this BSAT is a very interesting tool. One question I want to ask you, can the data and the emission factors used in in your tool considers as national and can be reputed, peer reviewed or something, so that we can use them in national calculations?
Yeah. This has gone through a rigorous reviewing process. So only the data that is applicable and following the specific standards are only being used here. We have gone for ISO standards. We have looked at, we have used the EPD international database and similar databases whenever possible. And also we have done our own life cycle assessment for different types of transportation and machinery following IPCC guidelines. That is how we have developed the database.
Thank you.
Thank you, sir. Thank you very much for the participation. I think we also lost a power. You might not be able to see me properly.
Yes, yeah. More questions? Nuan, can you hear us? If not, Nuan, hello?
Yeah, just now.
Shall we wind up the session if there are no any more questions?
Before winding up, I would like to thank Professor Shiromi for the wonderful guest lecture. And it was on a very informative and timely topic. And apart from Professor Shiromi, I would like to thank EUSL-Energy project and the Department of Mechanical Engineering of the Open University of Sri Lanka, and of course, SLAS Section C, and all the attendees for participating in this wonderful lecture. And we from SLAS Section C and from the EUSL-Energy project, we frequently organize webinars like this. Please be tuned with us, so I'm sure you will be able to gain a lot. And as a concluding remark, I would like to wish all the very best to Professor Shiromi and her team in further developing this much. And good night for the attendees from Sri Lanka. And good afternoon for the attendees from EU. Thank you very much.
Thank you very much for the kind invitation. Thank you very much.
Okay, the video will be uploaded, right? Because there's a request saying that they got a power cut. Don't worry, we will be uploading the recording. Okay, thank you, Professor Shiromi. Thank you very much.
You are welcome. Good night.
Good night.